Chapter 4, Personal Finance. Saving money, the power of compounding. Some terminology. Principal, the initial balance of an account. Simple interest, calculated by the interest rate to the principal only, not to interest earned. Simple interest formula. Simple interest earned is equal to principal times yearly interest rate times time. Example, we invest $2,000 in an account that pays simple interest of 4% each year. Find the interest earned after 5 years. Solution. The interest rate of 4% written as a decimal is 400ths. Simple interest earned is equal to principal times yearly interest rate times time in years. That's 2,000 times 400ths per year times 5 years is equal to $400. Compound interest is paid on the principal and on the interest that the account has already earned. In short, compound interest includes interest on the interest. Example, suppose that $1,000 is invested in an account earning 10% interest compounded annually. After 1 year, the account earns 10% of $1,000 or $100, the same as with the simple interest. At the end of the second year, the account earns 10% of $1,100 or $110. The account balance is $1,210 when the interest is compounded annually, but the account balance is only $1,200 for simple interest. Here two tables show how $1,000 grow with simple interest and yearly compoundings. In the first table, a constant interest is added to principal, right? The account grows by $100 each year. In yearly compounding, interest earned is added to the principal. The first year's interest is $100 and it's added to the principal, $1,000 principal. Our new principal for the second year is $1,100. And so the interest is increasing with each year. Compound interest. Interest paid on both the principal and on the interest that the account has earned. Compound interest formula. Balance after t periods is equal to principal times 1 plus r to the power of t. Alternatively, we can write the formula as balance after t periods is equal to principal times 1 plus APR, annual percentage rate, divided by n to the power of n times y, where interest is compounded n times per year and y is the number of years. This form is equivalent since r is equal to APR divided by n, and the number of periods is t equals to n times y. APR is annual percentage rate. Multiply the period interest rate by the number of periods in a year. APR formula, period interest rate is equal to APR divided by the number of periods in a year. Example, suppose we invest $10,000 in a 5-year certificate of deposit that pays an APR of 6%. What is the value of the mature CD if interest is compounded annually, quarterly, monthly, and daily? If the interest is compounded annually, the rate is the same as the APR. R is 6% or 600ths, and T is 5 years. Plug this into the formula. Balance after 5 years is principal times 1 plus r to the power of t equals to 10,000 times 1 plus 600ths to the power of 5, and it's equal to $13,382.26. Quarterly. R is a quarterly rate. APR divided by 4. 600ths divided by 4, or 15 thousandths. 5 years is 5 times 4 quarters. So t is 20 in compound interest formula. Balance after 5 years is principal times 1 plus r to the power of t, which is equal to 10,000 times 1 plus 15 thousandths to the power of 20, which is equal to $13,468.55. Monthly. R is monthly rate, or APR divided by 12, or 600ths divided by 12, which is 5 thousandths. 5 years is 5 times 12 months, or t is equal to 60. Balance after 5 years, principal times 1 plus r to the power of t equals to 10,000 times 1 plus 5,000 to the power of 60 equals to $13,488.50. Daily. R is daily rate equals to APR divided by 365 days equals to 600 divided by 365 days. That's equal to 16 100,000ths, which is the interest per day. 5 years is 5 times 365 equals to 1,825 days. Balance after 5 years is principal times 1 plus r to the power of t equals to 10,000 times 116 100,000ths to the power of 1,825, which is 13,498 and 26 cents. As the compounding periods increase, we get more money, but not that much more. Annual percentage yield, the actual percentage return earned in a year. APY is equal to 1 plus APR divided by n to the power of n minus 1, where n is the number of compounding periods per year. Example, you have an account that pays APR of 10%. If interest is compounded monthly, find the APY. Solution, APY is 10% or 1/10. N is 12, so we use the APY formula. APY is equal to 1 plus APR over n to the power of n minus 1 equals to 1 plus 1/10 divided by 12 to the power of 12 minus 1 equals to 1,047 10,000ths. Round the answer as a percentage to 2 decimal places. The APY is about 10 and 47/100%. APY balance formula. Balance after t years is equal to principal times 1 plus APY to the power of t. Example, in March 2014, a bank offered a 5-year CD at 1 900% APY. If you buy a $100,000 CD, calculate the balance at maturity. Solution, APY is 1 900%, which is 109 10,000ths. T is 5, and so we use APY balance formula. Balance after 10 years is principal times 1 plus APY to the power of y equals to 100,000 times 1 and 109 10,000ths to the power of 5 equals to $105,570.11. Present value. The amount we initially invest. Present value is principal. Future value. The value of the investment at some specific time in the future. Future value is balance after t periods. Compound interest formula. Balance after t periods is principal times 1 plus r to the power of t. And this formula is the same for future value. Future value is present value times 1 plus r to the power of t. Example, you would like to have 10,000 to buy a car 3 years from now. How much would you have to invest now in savings account that pays APR of 9% compounded monthly? R is equal to APR divided by 12 equals to 900 divided by 12 equals to 75 10,000ths. T is equal to 3 times 12 or 36 months. Solve the formula on the previous slide for present value, and we have present value is equal to future value divided by 1 plus r to the power of t. 10,000 divided by 1 and 75,000 to the power of 36, and that's equal to $7,641.49. Therefore, we should invest $7,641.49 now.